The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, today we're going to start reviewing for the final exam. We're going to go over concepts from the first two tests. The first test was from chapters, it was 3.7, 4.5, and then chapter 14. And then the second test was part of chapter 5. So we're going to start with section 3.7. So let's find that. Okay. So on the WebAssign screen, we see it says graph the inequality x minus y is less than 2. So first of all, we're going to take the inequality x minus y less than 2, and we're going to turn it into an equation temporarily. So we're going to take the equation x minus y equals 2. Then we're going to find two ordered pairs that are solutions to that equation. I don't have to, but typically I'll use the x and y intercepts. So to find the x-intercept, I'm going to set y equal to 0. And then to go on and find the y-intercept, I'll set x equal to 0. Now, if y is 0, we get x minus 0 equals 2, or x equals 2. If x is 0, we get 0 minus y equals 2. So negative y equals 2. Divide both sides by -1, and y equals -2. So now we have two ordered pairs that are solutions to the equation x minus y equals 2. But we have to keep in mind, in reality, we're dealing with x minus y is less than 2. So now we're going to go to the WebAssign screen. The first thing we're going to do, we're trying to form a line. So we're going to click on the line. Notice I have options: a line, array, a line segment. I need to have it be a line. So I click on the line till it turns blue. Then I'm going to go over and I'm going to plot the 2 points. 2, 0 is right there. 0, -2 is right there. Now, I've got a line formed. But if I go back here and look at my inequality, I see that it says x minus y is less than 2. It does not include the equal to part. So my line, let's see here, needs to be dashed. There we go. Okay, so it's a dashed line. It would only be a solid line if it includes equals to. All right, let me do some adjusting of the screen here. So now I have a dotted line. It says x minus y is less than 2. What I need to determine now is which side of this dashed line is the solution. So I'm going to pick a test point. I need to pick a point that is not on the line. I'll pick 0, 0. So I'm going to come back over to my whiteboard screen, and I'm going to take the point 0, 0 and see if it is a solution to the original inequality. So plugging the numbers in, I get 0 minus 0 less than 2, 0 less than 2. That is true. So my test point is good. That means that above the dashed line is the solution. So I click on fill, click on the side of the dotted line, dashed line that I want. So that should be my solution. Let's see if it is. And it says it's correct. So let's review the steps. What did we do? I took the inequality x minus y less than 2. I changed it into an equation temporarily. I found two ordered pairs that were solution to the equation. I plotted the two ordered pairs, clicking on the solid line till it turned blue, then plotting the 2 points. A line was formed. I went over to the line and I changed it to a dashed line. Then I went back and picked a test point, in this case 0, 0, plugged it into the original, found that it was true, so I shaded above the dashed line. So my solution is everything above, but not including the dashed line. All right, we're going to go on now to another problem where we're graphing a system of inequalities. So we have two solutions to graph. Okay, so let's take the first one, which is 5x plus 4y less than 20. All right, we're going to do the same thing we did on the previous problem to this inequality. We're going to consider its related equation, 5x plus 4y equals 20. We're going to find two ordered pairs that are solutions. I'm going to go ahead again and use the x and y intercepts. I don't have to, it's just convenient. I can pick other values, but I need to come up with two ordered pairs that are solutions. If y is 0, we get 5x plus 4 times 0 equals 20, or 5x plus 0 equals 20, or 5x equals 20. Divide both sides by 5x equals 4. If x equals 0, we get 5 times 0 plus 4y equals 20. 0 plus 4y equals 20. 4y equals 20. Divide by 4, y equals 5. So I now have two ordered pairs that are solutions to the equation, but that will allow me to graph the inequality. So I'm going to go over here and click on that until it's a solid line. I'm going to graph the point 4, 0, and 0, 5. I see that the original inequality does not have an equal sign. So I'm going to make it a dashed line. Okay. And then I need to see, I'll use what? 0, 0 as a test point again. Okay, so I'm going to plug 0, 0 in here. I get 5 times 0 plus 4 times 0 less than 20. 0 is less than 20. That's true. So that means that we're going to shade below that first line. So over here, we would shade right there. Okay. Now, let's go on and look at the second inequality. 4x minus y greater than 4. Tell you what, let's change the color of our pen to red. Okay, so we've got 4x minus y greater than 4. I'm going to take the related equation, which would be 4x minus y equals 4. I'm going to find two ordered pairs. Once again, I'll use the intercepts. If y is 0, I get 4x minus 0 equals 4. So 4x equals 4. Divide both sides by 4, x equals 1. If x is 0, 4 times 0 minus y equals 4. Negative y equals 4. Divide both sides by negative 1, y equals negative 4. So I'll come back over here, click on a line. I'm going to graph the points 1, 0, and 0, negative 4. Okay. Now, again, this original inequality does not have an equal sign. So line number 2 is also dashed. Okay. Now, let's take a test point for line number 2. 0, 0 is not on it. Let's use that as a test point. So 0, 0 would give us 4 times 0 minus 0 greater than 4. 0 is greater than 4. Not true. So for the second line, 0, 0 is not a solution, which means we're on the other side of it. So it's going to be to the right. Okay. So now, my first line, which was this one, I'm going to be shading below it. So it would be like, let's see here. Let's go back and, okay, let's see. To fill it, it would like be here and here, right? That's for the first line. The second line is to the right, so that would be here and here. Well, if we take these two and these two, where do they intersect? They intersect right there. That's the area that's shaded for both of them. Let's see if that's correct. And it is. So we basically did the same thing in this problem that we did in the other problem, but we did it twice for two different inequalities. Then we found where they overlapped, and that's the part that we shaded. So that was pretty much, that's section 4.5. We're going to go on and take a look at chapter 14. In chapter 14, the first thing we dealt with was factorials. So we have the problem, let's see, let's go back to, okay, to black ink. It shows up better. All right, so we have 9 factorial divided by 7 factorial. Now, recall 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. But I could also write 9 factorial as 9 times 8 times 7 factorial, because 7 factorial would represent all of that. So if I rewrite this as 9 times 8 times 7 factorial over 7 factorial, the 7 factorials will reduce down, and I'm left with 9 times 8, or 72. So the answer to this problem should just be 72. And it is. All right, let's take a look at this next one. Evaluate the expression. And we have 5 factorial over 2 factorial times 5 minus 2 factorial, which is 5 factorial over 2 factorial times, let's see, 5 minus 2 is 3 factorial. So what I can do, I can take 5 factorial and write it as 5 times 4 times 3 factorial. 2 factorial is 2 times 1, and 3 factorial will leave as 3 factorial. I guess I should keep using x's for multiplication. Then I could reduce out the 3 factorials. I could take the 4 over 2 and reduce it to 2 over 1, and I'm left with 10 over 1, or just 10. So the answer is 10. All right. Let's see here. Recall, well, yeah. Okay, we're going to go on. So this is section 14.2. And in this problem, they give us a specific sequence to use. And that is that a sub n equals 2n minus 7. It says find the first 4 terms. So we want to find a sub 1, a sub 2, a sub 3, and a sub 4. So using this specific formula that they've given us, a sub 1 would be 2 times 1 minus 7, which is negative 5. A sub 2 would be 2 times 2 minus 7, which is 4 minus 7, or negative 3. A sub 3 would be 2 times 3 minus 7, which is 6 minus 7, or negative 1. A sub 4 would be 2 times 4 minus 7, or 8 minus 7, or 1. All right, let's see here. So our list should be negative 5, comma, negative 3, comma, negative 1, comma, and positive 1. And it's correct. All right. Now, this next one says the first 3 terms of an arithmetic sequence are 6, negative 6, and negative 18. Find the 101st term. All right. Arithmetic sequence. So we're going to use a sub n equals a sub 1 plus n minus 1 times d, where d is referred to as the common difference. All right, so let's see here. I'm going to move this up a little further so I'm looking at the right term. So what do we know? We know that a sub 1 is 6, a sub 2 is negative 6, and a sub 3 is negative 18. We're supposed to try and find a sub 101. Now, we can find the common difference by taking any term in this arithmetic sequence minus the previous term. So let's take a sub 2 minus a sub 1. Negative 6 minus 6 would be negative 12. So D is negative 12. Let's confirm that by taking a sub 3 minus a sub 2. That's negative 18 minus negative 6, which is negative 18 plus 6, which is negative 12. Okay, so we've confirmed that D equals negative 12. All right, so now we're going to use this formula. A sub 101 equals a sub 1, which is 6 plus n, 101, minus 1 times D, which is negative 12. So this is equal to 6 plus 101 minus 1 would be 100 times negative 12, which is 6 plus negative 1200, which is negative 1194. So a sub 101 should be negative 1194. Let's see if it is. Negative 1194. And it is correct. Wonderful. All right, let's go on to this next problem. And let's see. It says, find the common difference, D, of an arithmetic sequence if its first term is negative 504 and the 23rd term is negative 592. All right, so it's an arithmetic sequence. So we're going to use a sub n equals a sub 1 plus n minus 1 times D. We know that a sub 1 is negative 504. And we know, let's see, a sub 23 is negative 592. We're supposed to find D. Okay, well, using the formula, we could say a sub 23 equals a sub 1, which is negative 504, plus n, which is 23 minus 1 times D. Okay? We could say that a sub 23 equals negative 504 plus 23 minus 1 is 22D. So we know that a sub 23 is negative 504 plus 22D. But we also know that a sub 23 equals negative 592. So that means that this equals that. Two different ways of describing a sub 23. So we get the equation negative 504 plus 22D equals negative 592. To solve for D, we'll add 504 to both sides of the equation. 22D equals, let's see, if we have negative 592 plus 504, we get negative 88. Dividing both sides by 22, D equals negative 4. So let's see if that's true. Negative 4, and it is. Okay, let's see, what do we got here? Let's talk about arithmetic means. It says find two arithmetic means between 11 and 19. Use your answers, enter your answers as a comma separated list. Okay, again, we're talking arithmetic means. So a sub n equals a sub 1 plus the quantity n minus 1 times D. If a sub 1 is 11 and we want two arithmetic means between 11 and 19, that means that 19 is a sub 4. All right. Now we can use the same information we used in the previous problem to find D. A sub 4 equals a sub 1 plus 4 minus 1 times D. A sub 4 equals 11 plus 3D. But a sub 4 also equals 19. So 11 plus 3D equals 19. So there's our equation we're going to use to find D. Subtract 11 from both sides. 3D equals 8. D equals 8/3. Okay. So now, let's see, what are we supposed to do? We'll find the two arithmetic means. So a sub 1 is 11. A sub 2, let's write over here. A sub 2 would be 11 plus 8/3. All right. I'm going to change that into an improper fraction, which would be 33/3 plus 8/3, or 41/3. How did I get that? I multiplied 11 over 1 by 3 over 3 to get a common denominator of a 3. Okay, 41/3. A sub 3 is 41/3 plus, what was it, 8/3, which is 49/3. And just to check, let's see, a sub 4 should be 49/3 plus 8/3, which is 57/3, which is 19. So it checks. All right, now find the two arithmetic means. So we're only going to put the arithmetic means in here. So it's going to be 41 divided by 3. And then I need to move the cursor over outside of the fraction, comma, space, 49 divided by 3. Again, make sure you don't put the comma down underneath there. All right, and let's see, let's look at geometric sequences, and then we'll go on to the next chapter. So it says find the sixth term of a geometric sequence with the first term of 1/25 and a common ratio of 5. All right, so for a geometric sequence, a sub n equals a sub 1 times r to the n minus 1 power. All right, we know that a sub 1 is 1/25, and the common ratio is 5. So we're to find the sixth term, okay? So a sub 6, that's what we're looking for. Well, using this formula, a sub 6 equals a sub 1, which is 1/25, times r, which is 5, to the 6 minus 1 power. The n minus 1 power, remember that n is 6 for this example, which is 1/25 times 5 to the 5th power, okay, which is, let's see here, 1/25 times 5 to the 5th power is 31/25, and 31/25 divided by 25 comes out nicely to 125. So here we go. All right, write the first 5 terms of the geometric sequence with 4th term of 7 and the 5th term of 7/2. Enter your answer as a comma separated list. So again, we're dealing with geometric terms. So a sub n equals a sub 1 times r to the n minus 1 power. We know that a sub 4 is 7 and a sub 5 is 7/2. And we want the first 5 terms, okay? Let's see here. What I should have done, I'm going to erase this for a minute here. Let's make some more room there. Okay. So what I'm going to do is this, because we're supposed to find the first 5 terms. So a sub 4 is 7 and a sub 5 is 7/2. All right. Well, if I could find the common ratio, I could work backwards. Just like with an arithmetic sequence, you take a term in the sequence minus the previous term. To find the common ratio, r, we're going to take a term in the sequence divided by the previous term. So we're going to take a sub 5 divided by a sub 4, which is 7 divided by 7/2, which is 7 divided by 7/2, which is 7 times 2/7, which is 2. You know what I did wrong? I wrote these numbers upside down, didn't I? So let's try that again. A sub 5 over a sub 4 would be 7/2 divided by 7, which is 7/2 divided by 7, which is 7/2 times 1/7, which is 1/2. I knew that that was wrong because to get from 7 to 7/2, you wouldn't multiply by 2. You'd multiply by 1/2. So the common ratio is 1/2. So if going in this direction, we're multiplying by 1/2, going in the other direction, we'd be dividing by 1/2. But that's the same thing as multiplying by 2. Think about it. 7/2 times 2 is 7, times 2 is 14, times 2 is 28, times 2 is 56. So tricky problem there. All right, write the first 5 terms separated by a comma. So 56, comma, space, 28, comma, space, 14, comma, space, 7, comma, space, 7/2. All right, find the first 3 terms of a geometric sequence that has a common ratio of -2, the 9th term of 32. So again, a geometric sequence. So a sub n equals a sub 1 times r to the n minus 1 power. We're supposed to find a sub 1. And we know that a sub 9 is 32, and the common ratio is -2. All right. So we can use this formula. For a sub n, we'll put in a sub 9, which equals a sub 1. We don't know what that is yet, times r, which is -2, to the 9 minus 1 power, which is a sub 1 times -2 to the 8th power, okay? Which is a sub 1 times, let's see, -2, the quantity. So -2 raised to the 8th power is 256. So a sub 9 is a sub 1 times 256. But we also know that a sub 9 is 32, right? They told us that. So that means a sub 1 times 256 equals 32. This equals that. Divide both sides by 256. A sub 1 equals 32 over 256. Let's see if that reduces to a nice fraction. 32 divided by 256 comes out to 0.125. And that is 1/8. And let's see here. Another way we could do that is we could say, well, let's take 32 divided by 32, and we get 1. 256 divided by 32, 256 divided by 32, and we get 8. So 1 divided by 8. All right. One more problem in this section. This is, I think, what, 14.3. Find 2 geometric means between -4 and 32. So geometric again, a sub n equals a sub 1 times r to the n minus 1 power. A sub 1 is -4. We have 2 geometric means, which means a sub 4 is 32. Okay, now we don't know what R is, but we know this. We know that A sub what? 32 is A sub 1, negative 4 times R to the 32 minus 1. Yeah, not 32, my bad. Hang on. Let's see here. All right, A sub 4 is 32. But I put in 32 and I should have been putting in A sub 4. So A sub 4 is A sub 1 times R to the 4 minus 1 power. And I had 32 minus 1 power there. A sub 4 equals negative 4R cubed. But A sub 4 also equals 32, which means negative 4R cubed equals 32. Divide both sides by negative 4. R cubed equals negative 8. Take the cube root of both sides, and we get R equals negative 2. Well, if R equals negative 2, negative 4 times negative 2 is 8. 8 times negative 2 is negative 16. Negative 16 times negative 2 is 32. So there's our two geometric means, 8 and negative 16. Okay. We're going to pause the recording for a minute while I get set up for the next chapter. All right, so now we're going to take a look at parts of chapter 5. Okay. And let's see. Let's take a look at problem number 1. Consider the polynomial 8x cubed minus x squared plus x plus 16. What is the lead term? The lead term would be the term with the highest power of the variable. So it would be 8x cubed. All right, so what am I going to put in there? 8, and then, let's see here, x. Nope, that's not what I wanted. Okay. Let's see, 8x cubed. There we go. All right. It says, simplify the polynomial and write the result in descending powers of a. So we have 5a squared b plus 7 minus 8a cubed b minus 4a squared b plus 2a cubed b plus 1. Let's see, those are like terms, and those are like terms, and those are like terms. We're supposed to put it in descending powers of a. So let's see, negative 8a cubed b plus 2a cubed b would be negative 6a cubed b. That takes care of those. Then 5a squared b minus 4a squared b would be plus a squared b. Don't put a 1 in front of it because WebAssign, it messes it up. You don't need it, it's implied anyway. And then 7 plus 1 is 8. In fact, let's do that. I'm going to put it, well, I'll put it in there and see if it takes it. It probably will take it now. Let's see. Negative 6a. Make sure you use the same case. Don't change it to uppercase. Cubed. And then b plus 1a squared, move it over, b plus 8. Let's see if it accepts it. No, it says it's wrong. Okay, so now we're going to go back and we're just going to get rid of that 1. All right, now, technically having the 1 there isn't wrong, but it's implied. You don't need it there. WebAssign doesn't accept it. So again, be careful with that. Okay, let's see. I'll look and see how much time we've got. We'll keep going here. Perform the operation. We've got 7.1a squared plus 2.2a minus 5.8 minus the quantity 3.7a squared minus 3.9a plus 12.8. I want to point out that when you have nothing in front of a set of parentheses or a plus sign, you just bring down what's there. But if you have a subtraction sign, you have to distribute that, which changes everything inside the parentheses. Okay, let's see. 7.1 minus 3.7. 7.1 minus 3.7 is 3.4a squared. 2.2a plus 3.9a, 3.9 plus 2.2 is plus 6.1a. And then let's see here, negative 5.8 minus 12.8 is minus 18.6. So let's see here, 3.4a squared, move the cursor over, plus 6.1a minus 18.6. All right, for the sake of time, I'm going to go down here and we'll take a look at this one. Negative 6x to the 5th z to the 4th times x to the 6th z cubed would be negative 6 what? X to the 11th z to the 7th. Multiplying powers with the same base, you add the exponents. So we get, let's see here. There we go. We get negative 6x to the 11th z to the 7th. And let's see, let's take a look at this one. Again, I'm not going to have time to get through everything. 2n squared times the quantity 2n squared minus 3n plus 5. 2n squared times 2n squared is 4n to the 4th. 2n squared times minus 3n is minus 6n cubed. And 2n squared times plus 5 is plus 10n squared. So 4n to the 4th minus 6n cubed plus 10n squared. All right. Let's do some foiling here. So we've got 2x plus 1 times x minus 1. So 2x times x is 2x squared. 2x times minus 1 is minus 2x. 1 times x is plus x. And plus 1 times minus 1 is minus 1. Combining like terms, 2x squared minus 1x minus 1. And again, don't put the 1 in front of the x. So 2x squared, move the cursor over, minus x minus 1. And let's see, how are we doing for time? I want to make sure, let's take a look at this one. Find the product. So if we've got a minus 4, the quantity squared, that's a minus 4 times a minus 4, okay? Which then is a squared minus, oh, well, here, be a squared, and then minus 4a plus 16. I was jumping ahead there. So a squared minus 8a plus 16. So a squared minus 8a plus 16. And what about this one? X plus 3 times x minus 3. That ends up being the difference of two squares. The two middle terms cancel, and we're left with x squared minus 9. X squared minus 9. All right, I want to go down to division because we're almost out of time here. So let's see here. Let's take a look at that one. Negative 10x squared y divided by 15xy to the 4th. Okay, so 10 over 15 is going to be what? 2 over 3. X squared over x is going to be x. And y over y to the 4th is 1 over y to the 3rd. So I've got negative 2x over 3y cubed. Okay. Now, I'm going to use a fraction. So the numerator is going to be negative 2x. And the denominator is going to be 3y cubed. Recall looking at this piece right here, if you have y over y to the 4th, that's y to the 1 minus 4, which is y to the negative 3, which is 1 over y cubed. Or you can take one y out of the top and one y out of the bottom to arrive there as well. Okay. If we have a polynomial divided by a monomial, such as this, 20a to the 5th b plus ab squared minus 25b all over 5a squared b. So a polynomial divided by a monomial, we rewrite it with each term in the numerator divided by the denominator. And then we'll go back and simplify each fraction, writing all exponents as positive numbers. 20 over 5 is 4 over 1. A to the 5th over a squared is a cubed, and b over b reduces down to 1. So I've got 4a cubed plus a over a squared is 1 over a, and b squared over b is b over 1. So plus b over 5a, and then minus 25 over 5 is 5 over 1. B over b is 1 over 1. So I've got what? 5 over a squared. And I know I went kind of quickly there, but I think if you go back and look at it, you can follow it. Cubed, okay, plus fraction Numerator is b, denominator is 5a, move the cursor out, minus fraction 5 divided by a squared. Okay, two more. We have a polynomial divided by a polynomial. So outside, I'm going to have x plus 2. Inside, I'm going to rearrange the numerator in descending powers, 2x squared plus 5x plus 2. Okay. So I'm going to take the leading term inside divided by the leading term outside. 2x squared divided by x is 2x, which goes up there. Then I'm going to take that 2x times the divisor, x plus 2, which is 2x squared plus 4x. Put that there. Subtract that quantity from what's up above. Change it to addition of the opposite. 2x squared plus negative 2x squared is 0. 5x plus negative 4x is 1x, and bring down the next term, plus 2. Start over, leading term divided by leading term. X divided by x is 1, so plus 1. Then we take the 1 times the divisor, and we get x plus 2. We're going to subtract that from what's up above, change it to addition of the opposite, add them up, we get 0 and 0. So the final answer, no remainder, just 2x plus 1. And finally, let's take a look at this one. We've got 4x plus 1 outside and negative 13x minus 3 plus 16x cubed inside. So outside, we're going to have 4x plus 1. Inside, not only do we need to rearrange them in descending powers, but we have a missing power. So it's going to be 16x cubed plus 0x squared minus 13x minus 3. Okay. Leading term divided by leading term. 16x cubed divided by 4x is 4x squared. 4x squared times the divisor, 4x plus 1, we get 16x cubed plus 4x squared. We're going to subtract that quantity from what's up above, change it to addition of the opposite. We get 0, and then 0x squared minus or plus negative 4x squared is negative 4x squared. Bring down the next term. Leading term divided by leading term. Negative 4x squared divided by 4x is minus 1x. So minus x. Almost messed up there. Then we're going to take minus x times the divisor. Negative 4x squared minus x. Distribute, plus, 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 0, negative 12x minus 3. Negative 12x divided by 4x is minus 3. Minus 3 times 4x plus 1, negative 12x minus 3. And subtract that, change it to addition of the opposite, and we get 0 remainder. So let's see. I know I'm kind of rushing here because I'm trying to get through before time runs out. And that's minus x minus 3. Let's see. All right, I didn't do one with a remainder. If you have a remainder, remember you write the remainder over the divisor. Okay, that's it for now. So stop the recording.